Hello. Hello. Okay. Trying out a different microphone today. I'm not sure if this will be better or worse, but it will be louder. Okay, let's get started. Number 166, fraction to recurring decimal. Medium, given two integers representing numerator and denominator of a fraction, return the fraction in string format. If the fractional part is repeating, enclose the repeating part in parentheses. If multiple answers are possible, return any of them. It is guaranteed that the length of the answer string is less than 1,000 for all given inputs. Note that if the, or maybe this is 10,000, I think it's 1,000. Note that if the fraction can be represented as a finite length string, you must return it. Okay, so 1 divided by 2 is 0.5, 2 divided by 1 is 2. 4 divided by 333 is 0. I guess this is 0, 1, 2, 0, 1, 2, 0, 1, 2. Is that what it means? Enclose the repeating part in parentheses. Okay. Well, I guess we have to remember how to do long division. I don't usually like to look up the concept while I'm solving the problem, but I don't remember how to do long division. So we're gonna have to invent long division to solve this. Or maybe we'll have to look it up. Not sure if I'll be able to invent it. Well, actually, I can... So the part before the decimal is going to be numerator I'm tempted to just say divided by denominator because it's an integer division, denominator. So string starts as this. That's going to be the part before the decimal. So 0, 2, 0. Then can we figure out how to do the part after the decimal without looking up long division? So for 1 divided by 2, how do you end up with 5? Do we know that the numerator and denominator are integers? Yes. right, anyone who knows how to do long division, this is going to be painful to watch. So yeah. So you got to figure out the repeating thing. I really have to know how to do long division. That would, if I could do that, I would just know the answer. But this is going to really take me a long time to invent long division. So you've got like 4, and then right, and then you've got 333. And then you want to know how many times. Is this the right way to write it? How many times does 4 go into 3 or something? Do you do it decimal by decimal? It can't be how many times does 4 go into 333, because that would give me too big of a number. So maybe you're supposed to put this out here and put the 4 in here. How many times does 333 go into 4? I just don't remember how to do this. I mean, it goes in 0 times, which is why I put a 0 somewhere. I'm not going to figure out how to do it like this. I don't know how to do this. We got to go from first principles. So can I turn a division into something that I do for each digit? Basically, 333 divided by 4 is equal to 3 times 100 plus 3 times 10 plus 3 times 1 divided by 4. If I distribute the division, then I end up with 3 over 4 times 100 plus 3 over 4 times 10 plus 3 over 4 times 1. right? So I think that means well, no, the issue is 4 could be multiple digits, and if I expanded this into a sum of its digits, I wouldn't be able to distribute it. So I know that this one will only be a number between 0 and 9, but this one could be a huge number, and I don't have a way to calculate this. Man, would this be easy if I just remembered how to do long division. I think I might have to... I'll think about it a bit more, but at some point I'll have to break my soft rule and just look up long division. Keep seeing if we can invent it from scratch, though, for a bit. This isn't even the right way around. I mean, that's right, but the example is showing 4 over 333. Yeah, and they can be anything. They can be big negative numbers. Okay. So if I had this divided by 3 times 100 plus 3 times 10 plus 3 times 1, then I could also distribute, I can't, no, I can't distribute the 4 here. What can I do? I mean, I can't distribute the 4, right? Like, if I just open up Python. 3 over 4 plus 30 over 4 plus 300 over 4. If I had 1 divided by all that. Oh, I can distribute the 4 like this. Okay, so I can say that this is equal to 1 over 3 over 4, 3 over 4, 3 over 4. But can I say 1 over 3 over 4 times 100 plus 3 over 4 times 10 plus 3/4 times 1. That's, and obviously I should open Python first. Is there a way to get rid of the 1 over and just say that this is 10 to the negative 1? 100 to the negative 1. I don't know if you can write it like this. No, that's not the same. All right, we're on our journey to invent division. Yeah, I can't just distribute. I would like to just distribute so I don't have to think about how long division works, but I think I have to actually figure out long division. So, 4 divided by 333. We know the first digit is figured out by saying how many times does 4 go into 330, or the other way around, how many times does 333 go into 4? In other words, and I think I should just leave the Python interpreter open here because I'm going to need to double check a lot of stuff. So we know that 3, or that 4 integer division 333 tells us how many times does 3 go into 444, or go into 4. How many times does 333 go into 4? So the first digit is 0. Or the number before the decimal is 0. Then how could we find the first number after the decimal? It would be something like, how many times does 333 go into 40? Or 40 divided by 333. And then 400 divided by 333 gives us the first 1. And then another 0 gives us 1, 2. That looks promising. Wait, this is giving us the sequence we want. I'm not actually sure why. Something I do remember from long division is that once it starts repeating, it keeps repeating. Okay, so let's add a period to ret, and then let's do what we just did. So while true, this will be the decimal part. Yeah, I'll just make it or we'll just keep adding it to ret. While true, numerator times a successive power of 10. So 10 to the I, and then I starts at 0. I will keep incrementing. Divided by denominator. That's going to give you the next digit. No. That's going to give you every digit. But would this just not work if I had more than a 2-digit number? So 4 divided by, or let's say I had 46 divided by 333. 0138138. And then let's say, or I mean, can I do 134? Yeah, so then this, when does this start repeating? Or is it not going to start repeating from decimal import fraction? Is that a thing? From fraction import fraction? From fractions import fraction. Okay. Fraction of 46,334. I want it with like a lot of digits. Might have to look that up. Python fraction digits. I don't want to cast it to a float because I want a lot of digits. Decimal. Do I have to import that? From decimal, import decimal, and get context. Conversion from fraction to decimal is not supported. But I guess you can divide two decimals together and keep the precision. Okay, that's what I was looking for. Get context dot precision equals 100. So where is the repetition here? I'm not seeing the repetition. All right, we're learning stuff about basic arithmetic. I thought if you had a regular rational number it would either repeat infinitely or it would end quickly. I didn't think you could get like these super long non-repeating patterns unless you had an irrational number. So I may be reduced to having to look up long division at this point. Also, what would I have to return in this example? Oh, they're guaranteeing me that they're not going to give me a string like that. Or maybe it can be like that, but they just won't. That was 100 digits. Maybe they won't give me one that'll. What if I say the precision is 10,000 and now give me this? Yeah, okay. So they're guaranteeing they won't give me a string like that or an input like that. That's crazy though. That's blowing my mind that you can get a decimal expansion that looks like this. Also just realizing I forgot to put decimal around to this one, but I don't think that matters. Okay. Okay, well here is a different way that I can cheat and not have to look up how to do no, that's not going to work. I was going to say what I could do is kind of binary search, and at each step figure out if I need to make my answer bigger or smaller, so that instead of learning the algorithm, I can just search and find an answer that works. But that's not going to tell me which parts repeat. I guess if I do it to very high precision, I can just see which parts end up repeating. Okay, that's my idea right now because I don't know how to do long division. So let's try this crazy idea. While, so we're gonna have ret, or let's just call it result equals, we'll start it at 1. While result times denominator is not equal to numerator. That's what I want, but that's gonna, what I need is a precision. So while result times denominator minus numerator, absolute value of this is less than some small number. Then at the end return string of result, which will obviously not work because we're not handling the repetition, we don't have the right precision, but just to see if this idea makes any sense. If numerator, or if this thing, So I'm going to use the Python walrus operator thing here. To define a variable inside the while condition and then use it outside. So if result is less than 0, that means my number is wait, res is not a good name for this because I've already got result. We call it diff. So if diff is less than 0, I'm trying to figure out if that means I need my answer to be bigger or smaller. So let's say my answer is too big. So result times denominator will be bigger than numerator. So if this is positive, then my answer is too big. So result needs to shrink. And now, how does it shrink? Because it's like I have a bunch of digits before the decimal and a bunch of digits after the decimal. And I started with just 1. So if that's too big, then I want to try moving to a smaller answer that's proportionally smaller than what I have. So I want to halve it. Result divide by equals 2. If diff is greater or less than 1, wait, this should be 0. If diff is less than 0, let's try multiplying our result by 2. But that has a problem because now we're going to be stuck bouncing back and forth. The thing is, I want to successively have smaller changes. The other thing is I can start the result so that it's correct here. Which should be result equals numerator integer division denominator. So it's like whatever is right, whatever's correct on the left-hand side, and then we're trying to add a factor that's between 0 and 1 to that. So these are the decimals. Start that at 0.5 because that's halfway between 0 and 1, and then we can binary search on this range. That's what we want. Binary search the decimals. This is getting a little hard to read, so I'm just going to say diff is result plus decimals. What can I call this? This is the side before the decimals. What is the word for that? Is that like divisor? So divisor plus decimals times the denominator. So this is my result times the denominator should be equal to the numerator minus numerator. So here what I'm saying is call this get diff. Diff equals get diff. While that's less than some threshold, we'll figure out the threshold thing in a second. If diff is greater than 0, here's where we want to binary search. So the amount that we're adding or subtracting should be changing over time. So I equals 0. If diff is greater than 0, then decimals the first time we move, we want to move by 0.25 because the range is between 0 and 1, and we want to binary search in there. So if we go right, we want to go right by 0.25, which would put us halfway between where we were, between 0.5 and 1. Or 0.25 would be halfway on the left, 0.75 would be halfway on the right. So what I want is you add if diff is too big, that means decimals was too big. So in this case, you subtract 0.5 times, or to the power of I, right? Because it's going to 0.5 to the power of 0 is 1. 1 is 0.5, 0.25, yeah. So I want to start this at 1. And then else plus equals this. So now we're binary searching our decimals. Then you can return divisor plus decimals. We said 1.0, then we said 2.5, then we said 0.5. So why is this not at all working? Let's print decimals. it's only executing once. And also for 0.5, it should have executed 0 times, because right, because decimals should have already started at 0.5. Get diff will give divisor, which should be 0, plus decimals, which should be 0.5, times denominator, which is 2, so that should give 1, minus numerator, which is 1, so that should give exactly 0, which is less than this. So we shouldn't have gone into the while loop. Print get diff, or here, just print diff and then decimals. Oh, what I want is, while it's bigger than the threshold, you have to keep making it better, not while it's smaller. Oh, infinite loop. So somehow there's a way to never get close enough. Why don't we print? We managed to get decimals to be 0. Oh, wait, we're bouncing back and forth. I never incremented I. Okay, we get the correct answer in one case. In case 2, we get 2.0 instead of 2. That's close enough. In case 3, we are getting closer and closer. 0.01201. What if we just add more decimals? Yeah, look at that. Okay. Now the insane part, which is we're just doing a calculation, and from that we have to figure out what is repeating. This may not be possible. But I think it's like, we saw an example where that wouldn't have worked, but that was also an example that they promised not to give us because they said the length of the answer string is less than 10 to the 4. I'm also curious, how many steps does it take to converge like this? So if you print I here, it took 48 steps. And what if I wanted 10 to the 4 digits of precision? Instead of having like 10 zeros here, I would have to have 1,000 zeros. So basically 10 to the power of 10 to the power of -4. Let me start with -2. Okay, that exits instantly. -3. -4. This is not giving the number that I thought it would be giving. I'm trying to say, oh, this one should be negative, this one should be positive. Okay, let's try 2. And then 3. Oh, at some point it stops working because my precision in Python is not high enough. Well, I can, from decimal, import decimal, or from decimals, import decimal. Turn this into a decimal. Does that change things? Yeah, that changes things. That makes it take way too long. Okay, so we can't go up to the amount of precision that it's telling us we would need to do. So I think we have to just figure out long division. I've got a little bit more of a feel for how to do it after implementing this part. So we can get the part before the decimal very easily. The part after the decimal, oops, is a number between 0 and 1. If I could just grab each digit one at a time, then I could start recognizing when they repeat. Like, I would probably have a way to tell that from the way I'm generating the digits. But how would I generate the digits? It would have to be like, so we I think it would have to be something like, I make it so that this would have been on the left of the decimal, I grab the divisor, and then I keep repeating. I grab the divisor mod 10. And then I make it so that this would have been left. That makes sense. That makes sense. So I multiply successively. Okay. All right. And that might be how you do long division, actually. Okay, so this gives me the number before the decimal. If I want one more digit, if I want this digit, then I can do numerator times 10, which would give me this number. Numerator times 10 divided by denominator. That would give me this result, because I multiplied it by 10. And now I take mod 10 to get this digit. Mod 10. Okay. And then I keep taking successive powers of 10. So for I in range 1,000, so we'll just grab 1,000 digits. This is to the power of I. This is to the power of I. We want to start I at 1. Don't print the digits, just make a result equals string of divisor, result decimals equals empty string, decimals plus equals string of next digit, return result plus dot plus decimals. So we obviously shouldn't have a bunch of 5s in our answer here. So numerator is 1. Oh, wait, actually, this one should always be mod 10. I don't want to grab any other digits. I always want to grab the last digit. Look at that. Okay. Okay. So where do we go from here? So the thing I'm trying to think of is, instead of recalculating it from scratch, one of the things I want to do is I want to know when I don't need to keep I want to know what the pattern is going to be. I want to know if it's going to be 0 from now on. I want to know if it's going to start repeating 0, 1, 2, 0, 1, 2. So the way I'm thinking of doing that is, instead of calculating each digit completely separately, starting from numerator and denominator, if I could have some kind of state that keeps updating, and then once I get back to the same state I've already been to, I know I can stop. So like, instead of doing this, it would be like times equals something, you know? So numerator, so we keep pushing stuff left of the decimal point. That's what this whole thing is doing. The integer division here makes it hard for me to keep some kind of rolling number, because I could do a regular division. Right, I could do a regular division and then keep multiplying by 10, but then I would lose precision. Because I'd only have as many digits as the floating point had when I did the first division. How can I know that I'm only going to get zeros from now on? That would be... I'm not sure. It would... I could like check if decimals is already correct. But that doesn't help me know that I'm only going to get 0, 1, 2 from now on. So numerator is 4, denominator is 333. For some reason, the next digit is going to be the same as doing 4 divided by 333. Wait, what am I trying to say? It's like 4,400, 4,400, but not quite. So this starts as 4 divided by 333, integer divided by 333, which would give us 0. Then it becomes 40 integer divided by 333. 40 integer divided by 333 is the first decimal point, so that's 0. Then it's 400 divided by 333, which is the second decimal point, which is 1. 400 goes into 333 once. 4,000 goes into 333 what, like 20-ish times? 4,000. No, 121. So the more you add zeros here, the more you're just getting well, okay, where are my zeros coming from then? If I'm taking this and then oh, because I'm doing 33 instead of 333. So the more I add zeros, the more I keep cycling between 0, 1, 2. Okay, I'm trying to think of some way that I could have a state so that I could recognize if I get back into the state. So let's say I had something like this that's like an intermediate result. I don't even know what to call it. Let's call it G. And we don't take the mod 10 of it. And we don't divide by the denominator of it. So now you've got G divided by denominator mod 10. And G is just times equals numerator on each step. Is that right? No. G starts as numerator, and at each step you multiply it by 10. The problem is G keeps getting bigger, so you never get back into the same state that you were. So now I'm wondering if you could if this thing if we could store this thing somehow. Because it's like... So this gives the same answer, right? I didn't break it. Yeah, this gives the right answer. It's cool. It's cool that it gives the right answer. It's like, it doesn't look like I'm doing division. So my problem is G keeps growing, and so I can't recognize that I'm back in the same state as before, because I never get back to the same state as before. G is different every time. I want to have some state that gets back to where it was whenever we are going to start repeating. I'm wondering if div mod can help me. So G and denominator. So I also, well, I don't think this helps. The other thing I was going to say is I know that there's a no, never mind. Okay, div mod gives you the divisor and the remainder. So it gives you the result of integer division, and then it gives you the result of the mod. So G mod this. And I'm wondering if there's a way to use the remainder to like construct the state that we need for the next thing. So, because this would be res. Just trying to think, when you divide, you're saying G integer division by denominator plus remainder. No. This is so annoying to have to figure this out from scratch instead of just remembering how to do it. So I'm trying to figure out how to do this in a stateful way so that instead of G always growing, or whatever, instead of G always growing, G is a function of what we had in the previous step, so that we could recognize a cycle. And I think it's going to have to do with using the remainder in some way that is very blurry to me right now. I don't know. I that's too hard for me to think about. So how would I know I'm done here? Why don't we try to, and this is not, like, I already know this is so not the right way to do this. The right way to do this is long division and then recognize when you're in a cycle and then put that in parentheses. But let's try to just do brute force division with more digits than we need. Like we could go 10 times more digits than we need. That's still pretty fast. And then post-process to recognize the cycles manually. So how do you recognize a cycle? So for I in range 1000, so this is going to be cycle starting points. I don't need the I here. So for cycle starting points, 0 to 1000. For end, or for length in range 1000. It's not going to go up to 1000. Although it could, right? Okay, just something that's been bothering me. Python 10 to the 4 is 10,000. I keep saying 1,000. It's 10,000. I mean, that's going to make this really slow, really slow. I mean, I just don't think they're going to give us cycles that are that long. Why don't we start with really short cycles that start really early, just to see if we can do this. If decimals starting at start and going until start plus length is equal to the same thing, but going to start times, or starting after start plus length and going to start plus length times 2. So imagine taking a slice out of the list of decimals and seeing if it repeats right after itself. This is not really going to work, but decimals, replace that slice with that slice, but with parentheses around it. Or, you know what, don't so f string parenthesis open close parenthesis close string. Replace everything for the rest of the string with that slice but with parentheses around it, and then return. String object does not support assignment. Yeah, you can't. You can slice a string, but you can't slice to overwrite values in a string. So let's make decimals not a string. It'll be a list of characters. I'm ending with an empty. Oh, don't count. Empty string doesn't count as a length that should repeat. Okay. This is what I want, but the format is just not right. So here you should just join. This is so horrible. I did have an end curly brace. Parentheses, start curly brace. Let me, digits equals this, digits, or pattern. Without this. Okay, 0 and then repeating 0, 1, 2. This is true, but there's a different way that it wants us to write this, which is if the pattern is 0, don't include it. Or, yeah. Oh, but do include the stuff before the pattern. Okay, if the pattern is 0 and decimals up to start, and not decimals up to start, then you do that. If the pattern is 0, then return result plus period plus the decimals up to when the pattern starts. And I don't need to say decimals up to start. I can just say end start, because if it's 0, that's when I don't want to do it. Okay, that gave 2. That gave 0.5. Why? Oh, because I put the same condition both times. How did I get 2 point nothing? How did I get 2 point and then nothing? I guess here I could, no. How do I get 2 point and then nothing? I have to be in this branch, right? Print hello. I am in this branch. If I have no decimals, oh. No. What are my decimals? Print decimals. I have a list. Print start. Oh, it starts with an empty. Wait, decimals. Why am I starting with an empty string? Wait, when did I do this? It should not start like that. It should start like this. Okay. All right, we've strung together an insane Rube Goldberg machine. I already know the kind of example that it's going to fail on. It's going to fail when the decimal is like 0, 0, 1, 2, 3, 4, 5, because it's going to think the 0 is repeating. And I'm not sure how to prevent that. So let's add that test case. We already know a test case that will fail, and that is if your numerator is 1 and your denominator is 1001. So we thought the 0 was repeating. So one way out of that would be to start with a bigger repeating pattern. But then I would say, like, okay, the pattern is 0, 0, 0, 9, 9, 9, 0, 0, 0, 9, 9, 9. So I guess for each thing that I think is a repeating pattern, I need to try smaller ones after that. Another way to say it is it needs to repeat all the way through the string, not just once. How can I easily check that? It would be something like if all from start plus length equals times, this is times I, and then it's all for I in range 100. How about 10? So if the beginning part is equal to start plus length times I up to I plus 1. Okay. All right, we're gonna submit it. This is an insane way to do it, and I think you could come up with examples where we'll fail. So let's see where we fail. We just are straight up not doing the correct thing when you when the number is negative, it looks like. So we don't even get the part before the decimal correct, which is interesting. Would we get it correct if we said 50? We would. So why does the like, how can the part before the decimal be already wrong? Maybe it's not, it's just that well, yeah, it must be already wrong. Oh, is it because the integer division is rounding towards 0, and that's, well, 50 divided by 8, negative 50 divided by 8, interesting. Okay, well, we can just add, we can just like, if numerator equals, it is less than 0, numerator, make it positive and remember that it was negative. Neg equals true, neg equals false. And then at the end, you don't even have to do it at the end, you can just do it right here. We'll say neg equals 1, neg equals negative 1, neg times divisor. Okay. Submit. I'm expecting a test case to fail where the pattern is more complicated. Oh, same problem with denominator. So you're negative if the numerator is less than 0, and denominator is greater than 0, or here, a different way to say that is if numerator less than 0, XOR denominator less than 0. And I don't know what the operator precedence is, so I'm going to put parentheses. Oh, I guess I'm multiplying the numerator, but I want to multiply whichever one is negative. No, what I want to do is if the numerator is less than 0, you do this. If the denominator is less than 0, you do the same thing, but for the denominator. And you don't have to multiply it back, like, oh, what? I just want them both to be positive. And then to have to remember to multiply back by the negative number if only one of them was negative. If they were both negative, then the negatives cancel out. So in this case, numerator is 7, denominator is 12. Numerator is not less than 0, so this won't happen. Denominator is less than 0. So denominator becomes positive. So now we're doing 7 divided by 12. Divisor is numerator divided by denominator, which will be 0. Oh, and then we're doing -0, which doesn't get remembered. So instead of doing that, we'll just say we'll use an F string. So we'll say yeah, we'll just do it like this. And neg should be the symbol minus. We'll just change it here. Equals the symbol minus if it's -1, else it's the symbol nothing. Submit. Give me the edge case I'm expecting. No, it's just more negative stuff. Okay. This is so annoying. It's unless the result is exactly 0. Which you can only figure out at the end. And that would have to be this case. Okay, this is the kind of edge case I was looking for. When you have a huge repeating pattern, this is more than 100. Can we just try bigger? The pattern still starts early, so can we just try bigger lengths? Yeah. Okay. Horrible solution. Horrible. Bad. Is there anything we can do to salvage any of this before taking a peek at the solutions and seeing how you would do it with actual long division? So how many digits is this? We need at least that many digits to before the pattern starts. $40. This is cheating. This is bad. Like, it's not cheating. It will find the right answer. We did have to put in some constants, though, that only make sense for the examples that it's checking. But this is not good. What would we rather have done? We would rather have figured out a way that the loop could come back to the same state so that we could recognize that we're in a state we've seen before, and therefore from now on there will be a repeating pattern. Instead, we are unable to recognize that we're in a repeating pattern, and we have to do that in post-processing, knowing how large the pattern may be from the constraints in the problem description. So let's take a look at what others have done. There's no code in this. Oh, there is. So this is the thing I was trying to do. Yeah, you append a minus, but he didn't remove the minuses, interestingly. Now you've got dividend and divisor. These are some words I was trying to remember. While a remainder is not equal to 0, you do the times 10 thing. I was so close. You do the times 10 thing. You keep track of the remainder, and now the remainder is the thing that's going to tell you if you're back in the state you were in before. I was really close. I just couldn't quite figure out how to do this in my head. Okay, next problem. Number 167, to sum 2. Input array is sorted, medium. Given a one-indexed array of integers numbers that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. Let these two numbers be numbers at index 1 and numbers at index 2, where 1 is less than or equal to index 1, is less than index 2, is less than or equal to numbers.length. Return the two indices of the two numbers, index 1 and index 2, added by 1 as an integer array from index 1 to index 2, or an integer array that has only index 1 and index 2 of length 2. The tests are generated such that there is exactly one solution. You may not use the same element twice. Your solution must use only constant extra space. Okay, so we're trying to find two numbers that will sum to the target, and we're returning the indices of the two numbers. So you've got, obviously, there's an n cubed solution, which is try every pair. We can obviously do better than that because the input array is sorted. So we can jump to we can find the values we want, basically. So so for each number, this actually is a n log n. For each number, binary search to find target minus, well, that's not going to help. Number. Because the idea here is if you can find target minus number, then you know you can make that sum. But you don't need to binary search to find target minus number. You can just go over the array, put the elements in a hash map or a set, and then for each number, see if target minus number is in the set, and that would be O of n. Oh, I see. Your solution must use only constant extra space. So that's why we can't just do the O of n solution. Only constant extra space. So n log n is a candidate then. So for each number, you binary search to find target minus that number. If you find it, you return the two indices. Is there any way to do it in n? I don't think there's going to be any way to do it in O of n. Well, there is actually. You can do it with 2 pointers. O of n, 2 pointers. So, you don't have to keep binary searching on the right side because you know that you're only ever going to have to go down the list as you go up the list on the left side. Like, you've got these numbers. Your first pointer is here, your last pointer is here. If this plus this is less than the target, then you want a bigger number, so you increment the left side because that will give you a bigger number to go in the sum. If this plus this is bigger than the target, then you want a smaller number, so you decrement the left side. And, well, yeah, so that means, well, hold on. The thing I'm trying to say is that you can skip the binary search because you already will be at the right place. So left side will go through each value. So for each left side, you want to know, is the corresponding right side that I need in the list? So you can start from the fully left side, fully right side, and move inwards until you see that you've gone too far. Okay? Then, if you put this back to what it was, one before you went too far, this is going to be a number that's too big. Now if you increment the left side to go to the next one, you know it's still a number that's too big. So the right side only ever has to decrement as the right side is going up. So that's how you do it. Left and right is equal to 0 and len of numbers minus 1. While left is less than right. No, I don't. I can go until all the way until the end of the list. So while L is less than len of numbers, but I have to stop if the right side goes below 0 also, because if either pointer gets to the end, then there's not going to be any more answers. So this should be and. Only while both are valid. This could be equal to 0. So the thing I want is that my current sum is always larger than target, larger or equal to target. So if numbers of L equals or plus numbers of R equals target, then we can just return that. It's they said it was one indexed, so I think that means return my index plus one. So if they're equal, you do that. Try spelling properly, it helps. If it's greater than target, then, well, okay, if it's less than target, then you just increment L. If it's greater than target, what I want to do is decrement R, but I also want to make sure that well, yeah, I can just decrement R. The thing I don't want is that when I increment the left side, now I'm going to wish I were one more to the right on the right side, but I'm not, because I will already know that I am. Well, I might, because that might be the thing that makes it equal. I'll know that this plus where I was on the right side. No, I will know that that is greater than target, because I already know that it's greater than target with the left side being a less than or smaller, or a less than or equal number. So I can just do this. And then what do you do if you don't find anything? It doesn't say. Oh, there's always a solution. So I can just do this. Submit. Ta-da! How can I do very marginally better? I can I don't want to call it sum, I'll just call it S. I can not repeat this sum. But I think the number of milliseconds is 100% variance at this point. Because we're basically not doing anything, and we're getting slightly different numbers of milliseconds. If I ran it a few more times, I'd probably get 0. Okay, next problem. Number 168, Excel sheet column title, easy. Given an integer column number, return its corresponding column title as it appears in an Excel sheet. For example, A becomes 1, B becomes 2, C becomes 3, etc. Z becomes 26, AA becomes 27, AB becomes 28. Okay, so this is pretty easy. what we want to do, wait, column number, oh, they wrote this in the, not in the direction that I was expecting. So I get an integer and I return a string. So what I want to do is while remainder, or I can just call it column number. Take this mod 26. So we get to do our div mod thing here. So div mod of column number and 26. You get the result and the remainder. The remainder is going to be a number between 0 and 26 that will tell us what character to have to add to our result. So the remainder, and then at the end we return ret. Remainder, I'm trying to remember how to do this in Python. So there's ord and char. CHR of 130. Okay. Where are the capital numbers? They're around like 80. Or the capital letters, I mean. 70, 67, 66. Okay, so 65 is a capital A. So we want plus 65. So I guess we want plus, yeah, we do want plus 65 because the remainder could be 0. So ret plus equals CHR of remainder plus 65. And then the remainder is column number. So we just keep doing that while there's still stuff remaining. No. The result is column number. So we divide out a 26 and then we keep doing that while there's still stuff remaining. We're off by 1 because 0 is not supposed to exist. I think that just means we should start column number with 1 less. No? Or with 1 more. Wait, how am I wrong in both directions? I'm outputting empty string. Oh. The issue is hold on. What? So if you give me 1, I'm giving you B because like I can't just add 1 less here because yeah, then I'm gonna be wrong. Hold on. Okay, why is this so hard for my brain to wrap my brain around? So when you give me 1, I say, okay, there's still stuff to do. Divide 1 by 26, but that's, yeah, divide 1 by 26. That's going to give 0 here, so we're not going to do more stuff after that. Remainder is going to be 1. Then we're going to add 65 to it, which is going to put us to the letter B. So if we did do 64 here, then the problem is if rem actually is 0, then we're printing something that comes before A. So you can't just do that. You need to make sure that rem can be a number between 0 and 25. So I guess I do think you just subtract 1 before you start. It's just that when you do that, well, I'm getting the wrong answer for these also. I'm off by 1 in the most annoying way. So you take mod 25, you subtract by 1, and you do mod 25, right? It's not called column. No, you can't take mod 25. You have to take mod 26. There's 26 letters in the alphabet. No matter how you start counting, there is 26. Why is this so hard for me to wrap my head around? No, I guess. This is embarrassing. How much I'm struggling to convert a number to a letter. So why am I saying ZAB? 701. Well, first of all, I'm appending stuff in the wrong order. The least significant one should be on the right. So ret equals this plus ret. That's one problem. I think the other problem is that I should start one lower than what you give me as input. So if you give me a 1, if you give me a 1, I'm supposed to give you an A. So, and if you give me a 27, then I'm supposed to give you an AA. But 27 would work for me, right? How am I getting both digits wrong? It's not like I can do this, right? Because that kind of works, but if you actually have a 0, what symbol is that? Is that a 64? Yeah. So how did we end up with 64 with the 0 here? And then a 1 in the next thing. So if your remainder is 0, so 701, div mod 26, gives you 2625. So now we know the first digit is whatever you get from 25. A 26 is supposed to represent a Z, but we're taking it mod 26. I mean, that's why I was trying to subtract 1 and then take it mod 26, because this is kind of saying take it mod 27, but that's not gonna work. Oh my god, how is this so hard that I've already taken 25 or 15 minutes just trying to take a number mod 26. So whenever it's 0, I'm screwing up. Well, in this, I don't know what I'm doing wrong in this case. 27, mod 26 is 1, so we're putting an A here. Oh, 20, I'm subtracting 1, so 27 is 26, mod 26 is 0, so I'm putting in A, and then there's a 1 remainder. 1 mod 26 is 1. No, there would be a 1 remainder. All right, I need to focus. Um, 27 mod 26 is 1. Therefore, the first digit is 1. The remainder is 1. So then the next digit is 1 mod 26. So the next digit is 1. If I just, let's try not converting them to characters for a second. Ret equals an f string that just has rem. I meant to put it around parentheses. So 1 and then 0. This is wrong because they should be the same thing. But I did do the subtraction here, so let's do that without messing with it. 1, 1, 1. 1, 0, 25. This is wrong. And if this is wrong, then I think I'm taking the mod, the wrong mod. So 1, 1, 0, 25, 26. But that's not right either, because I'm expecting 26, 25. Wait, this was already wrong. This shouldn't be 1, 0, it should be 1, 1. So let's bring the correct mod back. 1, 1, 1, 1, 0, 25. So how am I getting the wrong, how am I getting 1, 0. Oh. Because 0 means 26. So 0 should be the biggest character, not the smallest character. Yes. Okay. So you do this unless rem is 0. If rem equals 0, rem plus equals 26. And here you can do plus 64. Oh, I really thought that would work. Because now we don't have any zeros. We just have 1 through 26. 27. 1 through 27. So we div modded by 26. We got 1 and 0. And then we thought we had to recurse. But we don't have to recurse if we just got 1 and 0. But we do have to do this if you started on column number 1. Unless we did this, we moved this out of the loop. We moved rem to be equal to 0. But you can't do it fully out of the loop. You do have to because what I want is like if column number equals 1 and rem equals 26, then you don't keep going. But it seems like such an arbitrary rule. I know the solution to this is going to be so simple. I'm just like off by 1 somewhere. So here I'm off by 1 again. So actually it looks like what I have to do is column number minus equals 1 right here, but I'm not sure why. How am I struggling with this so much? I want to do this F string again so I can just focus on the actual numbers. 1, 26, 1, this is wrong. So don't do that. not equal to 0. I want greater than 0. 1, 1, 1. 126, 25, that's wrong. 226, that's wrong. Let's add a test case that's just the number 26. Wait. Add a test case that's just the number 26. So we're always saying, we're always like one number too big. I guess if we, maybe this is the way to do it. If we added one more to rem, but we always subtracted one from column. And we allow equal to 0. What is this? Because I'm at 0, so I should do plus 65. Hold on, what is CHR of 65? That's A. So how do I end up with square bracket? So 1, I subtract 1 from it, I'm at 0. So this is at 0. I do 0 mod, oh wait, I don't want to do this anymore if I'm doing this. Okay, finally. Subtracting 1 was the right thing. It's just that I have to do it for each of them. And then I have to make sure to allow 0 to be here. Okay, that took an embarrassing amount of time. But there it is. Next problem. Number 169, majority element. Difficulty easy. Given an array nums of size n, return the majority element. The majority element is the element that appears more than floor of n over 2 times. You may assume that the majority element always exists in the array. Okay. Okay, so we want to know the element that appears more than half the time. And I'm guessing we want to do this with one extra space, right? Yes, that's the follow-up here. So what you can do if you don't have the space requirement is you just count. You count everything, and then whatever had the highest count, you return that. With the space requirement, we'll have to be a little more creative. So we're going to want to do something where we only remember one number at a time, and we keep replacing which one it is, and we do it in such a way that at the end of it, if there was a majority element, we'll end up having it. It will have replaced the whatever else we were holding. So we could do a counter. I'm trying to think, like, if we had a counter, but we only ever counted whatever was currently the majority element, that doesn't really make sense, because half of your list could be stuff, or slightly less than half of your list could be stuff that you don't want to count. So if you had like a bunch of zeros and then one more one than zeros, or even more confusing, a bunch of zeros and twos and one more one than anything else, or than half the length of the list. Okay, here's a weird idea. That uses n log n, would be sort the list, take the middle element. So if the list is sorted, the middle element will always be the majority element. These will always be contiguous, and then there's no way to shift them around in the list where it's not on the middle element. This is n log n because sorting is n log n. Now, we can't do that because, first of all, because we're changing the input, which is kind of cheating if you have a restriction around the amount of space you can use, but you get around it by using the space in the input. Second of all, because this is n log n and it told us to do it in linear time. But can we do something similar to this? Not sure. So I'm trying to think if there's a way to do like some kind of bucket sorting. Bucket sorting can be efficient when you have a bound on like the size of the numbers. In this case, we don't have a bound on the size of the numbers, but we do know that most of the numbers will be in the same bucket. I don't think that helps us though. There's an interesting I have an interesting algorithm that is definitely not the answer, but it's a probabilistic algorithm, which is pick a random element, count the number of times that that element is there, when you're done your count, you'll know whether it's the correct answer or not, because you'll count that it has more than half of the elements in the list. If it was the correct answer, return it. If it wasn't the correct answer, repeat. So pick a random element. Each time you do it, you have a greater than 50% chance of succeeding. So that's a probabilistic algorithm that succeeds with 0.1 probability, which is kind of interesting. Like, this is the kind of algorithm that is used in theoretical stuff, like in quantum computing and stuff, but not usually, never in Leetcode. So this is a, like, you know what? It's an 0.1 time 0.1 chance of success. Return random element. Because you could just return the random element immediately and you get 0.1 time, which is kind of interesting. If you do it in 0.1 time, you can't tell if you were successful or not. You could convert this into an 0.n time to guarantee that when you do return, you return the right answer. All right, but that's not what we're trying to do. I'm still trying to think, is there a way to count, but only count the largest like subset? I don't see how, because in this case you'd end up storing. You don't know if any of the stuff you've seen so far at the time that you get to halfway through the list is going to be your majority element, so you'd have to, well, would you have to keep track of all of them, or can you forget some? What I'm trying to think is, like, if it's important, it'll show up more. It'll show up again. So let's say you only ever kept track of 2 counts at a time. No, that doesn't work, because you can't. You could miss the fact that something else is growing if you're not counting it. And they don't necessarily show up in a row, so you might keep forgetting it. You are guaranteed, if something is the majority element, oh no, never mind, you're not. Well, my best idea so far is to sort the list and grab the middle element. I'm sure there's some other clever thing like that you can do where you can kind of figure out the element by a property that it has from the fact that it is the majority element without having to actually count them. I can't do any kind of bucket sorting because there might be n over 2 other elements and I can't keep track of them. Or any kind of counting. I mean, I can't do any kind of count. I can't do a true count because I'd have to keep track of n over 2 other things. Okay. Now I'm trying to think of, like, if I look at the list 3 things at a time. No, this isn't gonna work because that's still counting. I'm trying to think, like, is it enough to, let's say I counted the majority element of this, the majority of this, the majority of this. The problem is I'm not going to end up with a count of 3 things. I'm going to end up with n over 3 counts of things, which would be more than O1 space. Sorting and grabbing the middle element is still my best idea. Like, I don't actually need them to be sorted, I just need the like elements to be next to each other. So contiguous elements to be equal. But I can't really do that either without either modifying the input list, which is kind of cheating, or storing ON extra space. But sometimes Leetcode problems don't count modifying the input as storing extra space, which is weird. I think they should, but sometimes they don't. So is there a way that we could cheat like that? Like, could we store the Could we do a kind of fake sorting of the list where we're just putting stuff together that is equal? I don't really know how to do that. Like, I could do it with a hash map and a linked list, but we'd end up with more space than we want. So yeah, like I could have a hash map and then each element of the hash map, but there's no point in doing that. You might as well just count if you're going to do that. Because I'm basically saying store a counter and then in the end put reconstruct the list from the counter. Okay, I'm kind of going in circles. Is there a way to count, but only guarantee that I've counted the majority element? I don't see how. Yeah, I don't see how. How do you do this? How do you do this? Oh! No. No. So I was thinking like you just keep one counter and every time you get the number 2 you increment it, every time you get the number 1 you decrement it, and then at the end if it's positive then the number 2 was your majority element. But that depends on you already knowing which is the candidate majority element. I'm trying to think, like, how would I, if you gave me 1,000,000 digits and you asked me what's the majority element, how would I figure it out? And I think I might be doing something like this, where it's like, oh, there seems to be a lot of 2s or whatever. Let's count the 2s. And then if I was right, I return it. The seems to be is like not guaranteed to be correct. So it's, you have a chance of success. The only way I would even have to count, no, I guess I would always have to count to make sure I'm right. But the only way it would be close is if there's another element that's like almost 2 over, or n over 2. So I should be able to like eyeball the candidates and then count them. But how do you eyeball candidates algorithmically? I can't like take any subset of the list and take a majority in there, because I might be taking a degenerate subset of the list. Like I could be looking at this part where there aren't even any 1s. But that's not what I would be doing if you gave me a list of 1,000,000 numbers. I wouldn't just look at the first page and say, maybe it's 0. I would skim the whole thing. But what am I actually doing when I'm skimming the whole thing and figuring out that there's that more than half of them are a certain number? It's like I'm counting the ones that are that number, and I'm counting everything else together. But how did I know to start counting that number? Because once you have a candidate, it's easy to check in O1 space and ON time if it's the majority element. But how do you generate candidates? I don't know how to describe what it is that I am doing if you gave me a real life list of 1,000,000 digits. I just look at all the numbers and I can immediately tell you what the candidates are, because one of them showed up a lot, but I didn't count them. But yeah, what do I mean one of them showed up a lot? How do I write code that tells you if one of them shows up a lot? There's such a gap between my intuition, because sometimes, or like often, when something would be easy for me, a human being, to do, I can convert like what is it that I am doing into an algorithm. And it's clear to me that if you give me 1,000,000 numbers, I could easily tell you what the majority element is. In O1 space, because I'm not counting all of the random numbers that aren't the majority element, I would only be counting like the majority element versus the other stuff. Because there can only be 2 candidates, really. One thing is going to show up n over 2 times, more than n over 2 times. If there's another candidate that's almost n over 2, then you have to count to figure out which one is the majority. If there's more than one other candidate, then each of those will show up less than 1 over 4 times. So there's really only ever 2 candidates at a time. But yeah, like, how do I know what the candidates are? Because in any given subset, you might end up saying that anything is a candidate. Any given constant size subset. This is so hard. This is labeled as easy. Although I bet, I don't know how they label their questions, but sometimes the questions are labeled easy when there's an easy solution, even if it's not the best solution. So sort and then take the middle is still my best idea, which is not a good idea because it's not linear space, it's not linear time, and it's arguably linear space depending on how you count space that's inside the input. Like we can do linear time and linear space by just counting. I have not been able to formalize the idea of just look at it, bro. Even though that's what I would do, and it would be fast and it would work. I think there's something to be said for there can only be 2 candidates, which means I only need to keep counts to keep a count of 2 things. Candidate means that it takes up almost n over 2 elements of the elements. But yeah, I just don't know how to keep a running count but not care about the things that don't appear very much. Because you don't know if they're gonna matter later. But it is kind of hard to come up with, well, okay, like here's, let's say we are only remembering we're counting, but we're only counting 2 things at a time. What does it mean that we're only counting the 2 biggest things? So when you get to here, you've counted the 0 and the 2, and then you keep going and you keep counting how many 0s and 2s there are, and now you have, now you're halfway through the list. We know that once we're halfway through the list, we have seen our majority element. So if we get halfway through the list and we've only seen a constant number of elements, then we can count all of them and finish with constant time. So let's say the constant is 10, for example. Or let's say it's 3. We've only, so in this example, we would be able to count the whole thing because there's only 3 things. But let's say we had this example and our constant is 3. So by the time we get to the halfway point, or actually right before we get to the halfway point, we've counted how many of 3 things there are. Then when we get to the halfway point, 3 is not enough. So let's say we evict the smallest count. Does something like that work? Could you count only 3 things and continually evict the smallest count? Would you be guaranteed not to evict the majority element? So if you had a lot of 1s in the beginning of the list, then yes, you're guaranteed. You're not guaranteed. You are guaranteed. You're not guaranteed. Because you could have something like this. 1, 1, 1. 0, 0, 0, 0. 2, 2, 2, 2. And now we need the rest of the 1s. So by the time you get to the halfway point, you have not evicted the 1s yet, the majority element. I also didn't put any 3s. I feel like this might be, I'm grasping at the idea here, is that like I can keep track of only a constant number, count them, evict the small counts, and because of the fact that the majority element shows up so much, either it's going to be really big and hard to evict by the time I get to the halfway point, or it's not about the halfway point. It's just either it's gonna get big fast, like if there's a lot of ones early, it'll be big fast, or in order to so either you won't be able to evict it because it'll already have a high count, or you would have to make your input such that it keeps getting evicted. So you'd have to have like 1 0 0 2 2 2 3 3. So now the 1's evicted. Then you go 1 0 0 2 2 3 3. Now the 1 is evicted again. But you can't keep that up and still be the majority element. Let's put a 4 on the end here. So in this case, 1 is not the majority element. I think that's going to be it. I just haven't, I don't have like a proof of why you can't keep that up and remain the majority. It just seems to me like if you're going to keep evicting it, like if you're going to keep evicting it, that means you have to keep having other number, you have to keep having a rolling count. You have to have too many windows where it's not the majority element. Yeah, I'm trying to say something like that. You won't be able to construct an input where you're able to evict it a bunch because you're going to run out of numbers that aren't it in order to evict it. I don't have a proof of it. It just, something like that seems right. So counter equals dictionary. We're going to store only 3 things at a time. We're only going to count 3 things at a time. For num in nums, if num in counter, or if num not in counter, then we evict something. For key in counter, counter of key let's just remember min key equals none. evict, here we if counter at min key, or not if, but just counter at num plus equals 1. This can be a default dict. From collections import default dict. So increase that, and then min key if counter of num is less. Wait, that's not how this would only let you keep the max key. So we do have to figure out the min key on the fly. So how do you evict? You would say counter for key in counter min key equals none. Min value equals negative infinity or just negative 1, because you can't count to less than 1. Actually, it could just be 0. Or actually, I want this to be the largest number so far, so this has to be infinity. From math import infinity. For key and counter, if counter of key is less than min value equals counter of key, min key equals key. So that finds us the key to delete, and then we can do del key. And then we have to, these should be dot keys. Isn't that already what it should be? No, key, this should be min key. This should be min key. And then at the end, return whatever has the biggest count. For key and counter, best equals 0. Wait, we should only evict if counter has more than if num not in counter and len of counter is greater than 3 or 2. For key and counter, if counter of key is greater than best. Or how about just best equals max of, no, because we have to remember what the key is. If counter of key is greater than best, best equals counter of key. Best key equals key, return key. So how are we, why don't you print the counter? There's 2 3s and there's 1 2. And then we're outputting 2 for some reason. Best key, if counter is greater than best, then this key should be my best key. How am I ending up returning 2? Oh, because I need to return best key. Okay. It's going to be hard to come up with inputs that make this fail, and I can just increase my constant until I find an input that makes it succeed. But even with 2, it was enough. But I'm not happy with this because I didn't prove I don't know, I don't actually have a proof that it's impossible to construct a input where I would fail to find the majority element. I have a feeling this is correct. I wasn't able to prove it. So let's take a look at people's solutions. Okay, this was the cool one I was thinking. Sort and then take the middle. But you can't do that if you want O1 space. And ON time. Yes, hash map of counting would also work, but that's O of n space. More voting algorithm. If there is a majority element in an array, it will always remain in the lead even after encountering other elements. And then is this going to be basically what we're doing? If count equals 0, candidate is num. If num equals candidate, okay, so the first time it encounters a number, it says that's my candidate. Then every time it finds, so this is basically with 1 as the constant, right? This is saying you only store the count of the biggest thing. Well, no, it's more like 2, but I said an idea like this where it's like you count the one that you're looking for, you subtract, and everything else counts as not this. The problem was I didn't know how to generate a candidate, but apparently you can always just take the next element as the candidate. Anytime you subtract it out, you can just say, all right, like anytime your count is 0, you can just say, okay, maybe the next thing is my candidate. This is making sense to me, because it's like, you can't spread out you can't spread out the non-majority elements in a way that will make you not find the count. Because if you try to swap it out at the end, it's going to be too late because your candidate has already been taken. If you intersperse them so that your candidate, like the true number, never has 2 in a row, you actually can't do that. There's guaranteed to be one location where there's 2 in a row, because there's one more than half of the elements in the list. So there's not enough space to separate all of them, which means, and if you did to try to separate all of them, then all of your other numbers would never get a count. Yeah, this doesn't really prove it. This is just like saying, yeah, it'll work. I don't know. It's like, this is a better version of what I'm doing. And it's for the same reasons as what I'm doing. It seems like it should be correct, but I don't really have the proof in my bones. You know, I don't have the feeling in my bones that it's impossible to okay, this is cheating. This is cheating. Okay, next problem. But this is good to know. More, what was it called? More something? Boyer-Moore algorithm. All right, next problem. Number 170, two-sum 3, data structure design premium. Difficulty easy. Design a data structure that accepts a stream of integers and checks if it has a pair of integers that sum up to a particular value. Implement the toSum class. toSum initializes the toSum object with an empty array initially. Void add int number adds number to the data structure. Boolean find int value returns true if there exists a pair of numbers whose sum is equal to value, otherwise it returns false. Okay, so we've done the toSum thing a few ways. One of them was even a few questions ago today. So the find tells me, or is supposed to return true if I can make this sum out of the values that I already know. So it seems to me like actually there's what should the runtime of this be? There's some trade-offs, I think. You can put more of the time in adding or more of the time in finding. You can't do them both in O1. You could do them both in log of n. So for example, maintain a sorted list. And there's also time. No, I guess there's no space trade-off here. You have to store O of n. So you could maintain a set and a sorted list whenever you add it to the right place in the sorted list. And whenever you end to the set, and whenever you find you binary search to see, well, no, never mind. I think find needs to take O of n space, or O of n time. So let me try to think this through. So find O of n would be for each num, check the set for value minus num. Checking the set is O1, for each num is the On. You can't do better than On. Right? Could you? Unless you like pre-processed for all of the values that someone might ask for. So yeah, I think you are just going to be storing a set. So you've got self dot, I don't want to call it set, I guess I'll call it set. Self dot set equals set. Add, you just do self dot set dot add number. And then find, you do for num in self dot set if value minus num in self dot set return true, otherwise return false. Submit that. Wrong answer. Oh, I am not correctly taking into account something summing with itself. That's not supposed to count, right? You need to, you shouldn't sum with yourself unless you have two of the same element. So I guess we could do this as a hash map. So let's just say self.data equals dictionary, which is going to be mapping int to int, from int to int, from numbers to count. So when you get a new number, you do self.data of number plus equals 1. Should be a default dict of int from collections import default dict. For each number in data, if it is in data, then you should also check if value, if self.data of this, or if this equals value, or I mean equals none, then you've already taken it out of the dictionary. So at that point, you should only return true if the value is greater or equal to 2. So if we don't, did they say anything about duplicates? Probably not, right? So something like this, or if it's in there, if you're equal to num, then if, I've got too many ifs here. If value minus num equals num, then it only counts if you have 2 in there. Otherwise, you should just continue. This number is not going to work. So the other way I can say this is, if it's less than 2, continue. And now I can combine these ifs. Okay. I'm also storing a little more than I need to, because I actually only care to count up to 2. So these could be Booleans where the existence of the key tells me that I have 1, and the value of true tells me that I have 2. So yeah, this could be a bool. This could be whenever you add 1, if it was there, you set it to true. If it was not, you set it to false. None of that is gonna matter here. But you could do that if you wanted to save more space and you had a profile of data that was that had a lot of duplicates. Then I don't think there's a way to do better than, so this is O of 1, obviously. I don't think there's a way to do better than O of n find unless you're pre-computing all of the possible things you could find when you add. So if we stored a 2D array of sums, in add, then adding could be O of n. Every time you add a new thing, you pre-compute its sum with all of the existing things. Finding could be O of 1. You just check if the value is in your set of reachable values. And then the amount of data you need to store is O of n squared, because it's 1 for each pair of elements. So depending on what you need to optimize, that's another way to do it. You can make add slow and find fast and store more data. Oh, no one, oh wait, I just, yeah, this is what we're doing. Okay. All right, well, that's it for today. I hope this was helpful. If it was, please give me a like on either YouTube or Leetcode. And that's all. Peace.